Hey guys, we are going to do, this is the very first lesson, check your understanding. All right, so lesson 1, and it is your check your understanding. So you should have attempted this in class or by yourself, and now you're just double checking to see if you have the right answers. I posted a video explaining how you could have gotten these answers or how some of the classes worked together to get them, okay? So I'm just going to restate. This is, kind of information in the same place. We notice here that it didn't start at 0, which maybe doesn't matter, except if I redrew the graph and it started at 0, then let's see if that would look different. So let's see. This goes almost up to 200,000. So that would be 100,000. That'd be 150,000. So the first one is a little bit bigger than 150. The next one is 170, so a little bit bigger than that. And the last one is a little bit shy of 200. Notice it doesn't look like, apprehension means worries. If you're worrying about the border, you might be worrying. That's happening in Afghanistan and China and Russia right now. They're worried that Afghans are going to come over the border. And those people don't have money and they don't have food and they need to be taken care of, right? So that's a concern. If we look at this picture that does include 0, it looks like it's going up each year, but not by a lot. So when they cut off the bottom, it makes it look like there's more growth than there really is. Okay, I gave you a lot of other ways on the other video to say that, but I'm just kind of summarizing. Okay, here I'm hopeful that, and I think in most classes, students did this. Notice we can't do a lot of our calculations without these subtotals, and I call this my grand total, subtotal and grand totals. So let me just jot in my subtotals here. And this is my total, and these are my totals, right? Now with that, it says what proportion of the houses? So it looks like we took data on 220 houses. So the proportion would be out of 120. So out of those 220 houses, how many were built in pine? So that looks like 60 were built in pine. So 60. And I've shown a proportion. You can also show it as a decimal. All right, next it says find the distribution of decade built for the houses in this town using relative frequencies. So relative to each decade. Relative to each decade. Okay, so in the 1960s, it looks like the distribution of decades. So in the 60s, 100 were built out of the 220. In the 70s, and 90 were built out of the 220. And in the 80s, 30 were built out of the 220. Okay. Now we could show this as percentages because usually this is what helps us like, well, what percent, right? So we could convert that to 46%, turning it into a decimal, and then moving the decimal. And then this would be 14%. Now, what percent of homes were built in Oak Crest and So when we have this and happening, that means we want Oakcrest and in the 60s. So we want the overlap of that, this digit right there. And it says what percent of the homes. So I have to think it's of all homes still. So out of the 220 homes, it looks like it's 60 out of the 220. Okay, that should give us this decimal. And it says a percent, so I'm going to convert it to percent. And you can round it to 27 or whatever, you know. This class is not as specific about rounding. So what concepts should you kind of pull together from the activity and the check your understanding? And that's where I put these here. So again, these are just to kind of help you sort your thoughts. So the first learning target in class was we're collecting categorical data. We're asking questions that are yes or no answers. Okay, to do that, we can either report it as actual numbers or counts, right? 5 people said music, right? Or we could do percents, right? That's called relative frequency. Okay, so if it was 5 out of 10 said music, I could say 50%. That's your relative frequency. What could we show it in? Well, we noticed we could show it in a pie chart or graph, right? We could show it in a bar graph. We call that a bar chart or a bar graph. We noticed if we asked 2 variables, we could show it in a side-by-side. Or a segmented bar graph. And this is probably in your notes somewhere. So you probably don't have to write this down. It's probably just a redundant. So what is our second learning target? All right, our learning target today, we didn't really notice it, but if you get good at making it, the more graphs you make, the more you'll notice, wait, that one wasn't made right. So we're learning how to properly make them, and part of that learning goal is to think and look at graphs made poorly. So we noticed in our check your understanding, we want to watch out if they mess up the vertical axis, right? This is the example for that here. We also want to watch out, so what was wrong with it? It should have started at 0. All right, the other thing we should watch out for, I don't see an example here, but when I give you some homework on this, you'll see this example in the book. You want to be careful of pictograms or graphs. All right, that is when they use in the graph, they'll use like a house, and then the house will actually get bigger. They'll use pictures instead of bars. Okay, last learning target is a two-way table, right? Mostly we use two-way tables to sort this information. So I just want to give you, the general idea here. Usually we put the first variable here. We saw that. And then the second variable there. Notice oftentimes these could be interchanged. Whatever number we decide to put in here, that's definitely a piece of raw data. Whatever goes off to the side over here in our total, that would be your marginal subtotal. And remember, this number here ends up being your grand total, right? So what kind of things do we calculate here? And what kind of things do we also calculate? Do you remember here in our graph? These. What type of calculations were these? And how did I know which number to grab? Okay. Well, if they ask you to find the marginal, and this will come up in the book, if they ask you to find the marginal relative frequency, Then you're going to take the margin total, B, divided by C. If they ask you to use the joint relative frequency, then that's the joint. Use this phraseology in class a couple different times. That's A over C. We saw that came up in the last example here, and it came up, I think, in the second question in class. That's called the joint relative frequency. And a conditional relative frequency happens when they ask you to take A over B. So it's conditioned on just this first variable. So like maybe just the music people, and your denominator is now no longer the grand total. That's called a conditional relative frequency. Last but not least, the thing we've been working on consistently is whether or not there's an association, okay? So that was the main part of the lesson, and it's actually the main part of lesson 2 as well. Is there some kind of an association between two variables? And what does that mean? We're working on finding out. It means knowing one affects the other. All right, thanks for joining me. Have a good one.